In part 2 of this extended interview, we continue our discussion with Thunderbolt's Picture of the Day managing editor Stephen Smith on the electrical scarring of planets and moons. We now turn our attention to Mars as we explore the evidence that electrical discharges dramatically carved the Martian surface. We begin by asking the question, did excavated material from the surface of Mars arrive on Earth as Martian meteorites?
Martian meteorites, as their name implies, are supposedly pieces of the planet Mars that have reached our planet. They're usually identified by their mineral and isotope content because various Mars landers have analyzed the soils there, and those analyses are used for comparison. So comparing the analysis from, say, the Spirit and Opportunity rovers with the analysis of meteorites found sometimes in Antarctica, they've concluded that they are actually pieces of Mars. So to discuss Martian meteorites, we have to talk first about how they might have migrated from Mars to Earth. In the last interview, I mentioned Valles Marineris. It's a canyon on Mars that's 4 times deeper than the Grand Canyon, and it runs for almost 5,000 kilometers. When the Mariner space probe sent back pictures of it, the first thoughts were that it was formed by some sort of catastrophic flooding. But a major difficulty with that theory is that there's no delta or headwater region in the canyon, and there's no debris field that might be left over from water erosion. Also, there's no indication of surface accumulation of water anywhere nearby in lakes or ponds that might have formed because of the catastrophic flood that supposedly cut out the canyon. Also, the so-called tributaries in Valles Marineris terminate in clean cuts, and there's no sign of water flowing down into them. They don't look in any way like a typical drainage formation. The Mars Reconnaissance Orbiter also saw evidence of olivine inside an area called Ganges Chasma, which is one of the deepest parts of Valles Marineris. And because olivine reacts with water, its presence seems to definitely exclude water erosion as the cause of the canyon. So we have to ask ourselves, what force is it that can excavate over 2 million cubic kilometers of rock and regolith from the Martian crust? And modern geologists speculate that Valles Marineris was formed by what they call mass wasting, meaning landslides or slow movement of material down a steep slope, usually in the presence of water. And since Mars is thought by many planetary scientists to once have been warm and wet millions of years ago, though, that influence still pervades their thinking. As I said in the last segment, investigators were stunned by the images of Mars from space probes that showed it to be more like the moon with its craters, rills, and its sharp peaks. Their theories suggested that Mars should be inactive with a surface that was relatively stable for millions of years. Nothing like the scale of Valles Marineris was even imagined. So then back to the question of what did carve up Mars like a pumpkin. In the 70s, Ralph Jurgens, a civil engineer and a participant with Dave and Steve Talbot in the magazine Ponce, thought that electric arcs between planetary bodies created the features we see on Mars, as well as the moon, and by extension, most likely Earth. So here's a quote from Jurgens. He said, "This entire region resembles nothing so much as an area zapped by a powerful electric arc advancing unsteadily across the surface, occasionally splitting in two and now and then weakening so that its traces narrow and even degrade into lines of disconnected craters." And indeed, in many areas of Valles Marineris, there are long lines of crater chains. Electric universe physicist Thornhill also wrote, "Valles Marineris was created within minutes by a giant electric arc sweeping across the surface of Mars. Rock and soil were lifted into space, and some fell back to create the great strewn fields of boulders first seen by the Viking and Pathfinder landers." And Wall's analysis suggests that the discharges resemble the shape of a barred spiral galaxy, in Valles Marineris. And the listeners can read about Wall's theory in more detail on his holoscience.com website. And in particular, they should read his article called Spiral Galaxies and Grand Canyons. So, like an arc welder shoots sparks and flux into the air when it fuses metals, material from the electric arcs that hit Mars shot gigatons of regolith out into space, and this exceeded the planet's escape velocity. This means that whatever electric force excised Valles Marineris probably threw huge chunks into space. Some of them undoubtedly fell back to the surface, as Wall mentioned, but some of them of the larger pieces most likely entered orbit. And one of my latest Picture of the Day articles discusses the moon Phobos and its obvious electrical scarring. One of the major objections to the idea of explosions of that magnitude is that they would have melted or disintegrated large pieces of rock. However, electrical acceleration doesn't do that. Just like electromagnetic linear induction motors can cause rapid acceleration, the upward pull of electric arcs does the same thing. And many people might be familiar with the linear induction motors in the amusement park ride called Superman that accelerates the cars to 100 miles an hour in 3 seconds and without heat. And the characteristic of electricity that I mentioned, that it can cause rapid acceleration, helps to explain the features on Phobos. As I mentioned, I recently wrote that Stickney Crater on Phobos is 10 kilometers wide, which is nearly the same size as Phobos itself. I've also written many previous articles that talk about rocky bodies with craters almost as large as they are, and I mentioned Saturn's moon Tethys last time as an example. As I pointed out, the so-called impact craters should have blasted the objects apart, but there's really no indication visible other than the large craters. In the case of Phobos, Phobos is like 28 by 20 kilometers in size, so Stickney Crater is nearly half as large as the moon itself. Some astronomers say, or they claim, that the fracture lines around Stickney Crater show that there was a great shock to the moon and that it was distorted by whatever formed Stickney Crater. But when you look closer, you can see that the striations that they're mentioning are really chains of small craters. And there aren't any fracture lines, as they call them. There aren't any cracks from a huge shock wave passing through the moon. Surrounding Stickney Crater, it's smooth and rounded, and there's no large blast debris. And it should be mentioned, though, that Phobos itself is covered with about a meter thick carpet of ultrafine dust. And I know I mentioned last time Comet Hartley being electrically machined and the surface of the comet being surrounded by a cloud of ultrafine dust. And it's probably something similar to do with Phobos during whatever electrical event created it. Since Phobos is about the same size as some asteroids, like Matilda or Eros or Ida, and it has gigantic craters just like they do, we have to ask ourselves what common event creates similar structures without blowing them apart. And the only answer that I can come up with is electricity.
Planetary scientists theorize that volcanoes and flowing lava are responsible for having shaped many of Mars' most dramatic features. But does this explanation match what is actually seen on the Martian surface?
Another thing about Mars is there are long canyons and rills that seem to start and stop suddenly. Even though Valles Marineris has been attributed to mass wasting or flooding by conventional geologists, the other abrupt incisions on the surface are even more puzzling to them. And the only explanation that they've been able to come up with is that they're lava tubes from volcanic eruptions. And lava tubes form when volcanoes send rivers of molten magma down their slopes. And as the lava hardens, it supposedly forms a shell around the flowing stream. And indeed, that is true, because you can see that there are lava channels around many volcanoes with roofs over them, and holes through the roofs show that molten rock is indeed flowing through this shell. Since the shell creates a roof over the lava, it insulates it and it allows it to travel for many kilometers. And lava tubes are found in Hawaii and other places around the world, like New Zealand, or wherever volcanic eruptions have been frequent over the centuries. We can see the evidence for collapsed lava tubes in Hawaii, and they superficially do resemble the structures on Mars. However, one important objection that I can point out is there's no sign of any volcanoes associated with most of these big trenches that are supposedly collapsed lava tubes. And another objection is the evidence of collapse that we can see on Earth. When the roof of a lava tube collapses, they're often several meters thick of solid rock. So the roof has really nowhere else to go except into the bottom of the lava tube. So there's big piles of fractured rock and stone covering the floors of these tubes. But when you look at the Martian formations, the bottoms of these trenches are clean. And there's really maybe just a dusting of sandy ripples in there. So you have to ask, well, where's the roof of this collapsed lava tube? Since the long trenches, and I could name a couple of them like Tractus Catena or Coprates Catena, have steep, clean sides, and they have scalloped edges. Like I mentioned the last time, Victoria Crater has these scalloped edges. So do the sides of some of these trenches. They often have dendritic ridges going at their sides too. So I'd suggest, based on the evidence that I presented last time and some of the things that Dave Talbot has done about dendritic ridges, that these trenches mark areas where electric discharges touched down and then traveled along for some distance before they were suddenly quenched. So C.J. Ransom, who I mentioned in the last interview, has created similar features in his laboratory, these trenches with clean bottoms and steep sides. And he's done it by exposing these various materials he's formed to electric arcs. And he's either moved the discharge electrode across the sample or he's moved the sample under the arc. And that shows me that the lightning bolts that etched the deep furrows on Mars were either moving through space above the planet or the planet was rotating under the discharge that was emitted by whatever electrically charged object was above its surface. It's true that many Martian trenches are near what are conventionally called volcanoes, but I have serious reservations about that description as well. One of the most familiar formations on Mars is probably Olympus Mons in the northern region. And it's often called the, quote, largest volcano in the solar system, unquote, because it rises more than 27 kilometers. That's 3 times taller than Mount Everest. It's also almost 600 kilometers wide across its base. In comparison, the volcano on Hawaii, Mauna Kea, when you measure it from the ocean floor to its summit, is a little over 10 kilometers high. So here you have a volcano, so-called on Mars, that's 2.5 times higher than Mauna Kea. But like I said, there are serious issues with the description of Olympus Mons as a volcano, and particularly in the sense that it's a place in the crust of Mars where supposedly molten magma erupted from beneath the surface, building up a conical structure. Although I should mention in passing that volcanoes on Earth might not behave in the same way as everyone assumes. So using volcanoes on Earth to describe Olympus Mars might be more of a hindrance than a help. In the case of Olympus Mons, though, the structure is definitely anomalous. First of all, when electric arcs strike a surface, they often will stick to one spot, and that causes the surface to melt, sometimes creating bubbles or blisters. And those blisters are known as fulgamites or lightning blisters. And that terminology I first learned from Wal Thornhill many years ago when he released his CD-ROM called The Electric Universe. Unfortunately, that particular presentation is now out of production, but Wall's various talks in a number of different venues discussed nearly everything that was found there. Many of his talks are available through the Thunderbolts website, by the way. But getting back to Olympus Mons, Fulgamites are sometimes seen on lightning rods after they've been struck. They're bell-shaped blisters with nearly circular craters on top of the blister. They have steep sides and they're surrounded by depressions or moats, as I briefly touched on in the last interview. They also rise up sharply from vertical sidewalls. And of course, anyone who's looked closely at images of Olympus Mons can see those same distinguishing characteristics. These vertical sidewalls surround Olympus Mons, then there's a steep upward rise in a bell shape and multiple circular craters on top of the volcano. I keep referring it to as a volcano, but let's call it a fulgamite, which it most likely is. Then again, close by Olympus Mons, you've got three other gigantic so-called volcanoes that share the same features as Olympus Mons does. The other three are found in a straight line just to the southeast of Olympus Mons. And to me, this means that the volcanoes on Mars are really gigantic lightning blisters. And in my last interview, I stressed that using Earth geological theories to model the rest of the solar system is backwards thinking. Rather, we ought to use what we see in the solar system to model Earth geology. In the case of the huge fulgamites on Mars, perhaps many or maybe even all volcanic formations on Earth can be traced to the activity of electric arcs at some time in the recent past. And in that light, there's a structure in Namibia called the Brandberg Massif that ought to be analyzed in terms of fulgamite morphology, because the Brandberg Massif is a circular dome-shaped structure. It rises more than 2,500 meters, and it's an area bigger than 650 square kilometers. It's described by geologists as being over 120 million years old, and they think it's a granitic intrusion that's so supposedly punched through Earth's crust long ago, of course, 120 million years. And but you know, when you look at Brandberg Massif, near it are parallel grooves and ridges that extend outward from it for hundreds of miles, and there are Lichtenberg figures covering an enormous area, multiple craters with strange shapes, and dunes that seem to be frozen in place. But when you look closer, you can see that the so-called dunes are really solid rock waves that march across the desert. They're covered by only a thin layer of sand. And parallel grooves like this are everywhere in the solar system. On Venus, which is the hottest spot in the solar system, on Enceladus, which is profoundly cold near the temperature of absolute zero. And if these patterns are found in such different environments, then we have to search for a common explanation for them that has to take all that variability into account. And I mentioned Lichtenberg figures a moment ago. They're named for George Christoph Lichtenberg, and they form when lightning bolts strike some material on Earth. It can be soil or sometimes even human tissue. I've seen images on the web of human beings that have been struck by lightning, and these branching Lichtenberg figures are burned into their flesh. And Lichtenberg figures have also been generated artificially in blocks of acrylic plastic by a man named Bert Hickman, who sells what he calls captured lightning sculptures on his website. Also, many Lichtenberg figures have been discovered in the south polar region of Mars, and we've referred to them in some pictures of the day as Martian spiders. But we're not going to get into the Martian spiders too much here today. So if the topography surrounding the Brandberg Massif and the Brandberg Massif itself exhibits details that are found on other planets and moons, then conventional theories are going to fall really short of the observations. By describing the birth of the Brandberg Massif as an event that emerged gradually in the distant past, basically planetary scientists are neglecting observational evidence. And that evidence is that the formation is in reality a fulgamite of huge proportions that might have been formed suddenly. Again, I know that this idea sounds far-fetched since Earth geology has been well thought out and explained for the last 100 years or more. But I will say, though, that one well-known geologist that I know has been heavily influenced by these concepts, so much so that he's changed his opinion about some Earth-based structures and now says he's re-examining his opinions about how they formed in light of new knowledge that he's gained about electrical events. So this shows you that once the mind opens to new ideas and a new way of seeing the world is allowed to take hold, things that once seemed so settled and stable suddenly take on a whole new aspect. A new way of seeing the world evolves. This change in thought processes is sometimes described as a catastrophic shift in perception by psychologists. That shift in perception was described in the title of the last Thunderbolts conference. It's called a tipping point. When you push on a tall object, it slowly moves off center until it reaches the point of no return and tips over without further energy input because gravity takes hold. And that same psychological impetus occurs in the mind. Slowly, new ideas begin to build on one another until the old mindset topples. And a perfect illustration of that would be the fall of the Soviet Union, if you're talking about it from a psychological standpoint. I remember hearing about Hungary taking down their walled borders with the West one day, and then it seems like only a couple weeks later that Lech Walesa started the Solidarity movement, and then a couple weeks after that we saw the East German Wall come down. I realize it took longer than that, of course, but it seems like once the ball starts rolling, changes become inevitable. Because various Mars landers have analyzed the soils there, and those analyses are used from comparison. So, comparing the analysis from, say, the Spirit and Opportunity rovers with the analysis of meteorites found sometimes in Antarctica, they've concluded that they are actually pieces of Mars. So, to discuss Martian meteorites, we have to talk first about how they might have migrated from Mars to Earth. In the last interview, I mentioned Valles Marineris. It's a canyon on Mars that's 4 times deeper than the Grand Canyon, and it runs for almost 5,000 kilometers. When the Mariner space probe sent back pictures of it, the first thoughts were that it was formed by some sort of, though, that influence still pervades their thinking. As I said in the last segment, investigators were stunned by the images of Mars from space probes that showed it to be more like the moon with its craters, rills, and its sharp peaks. Their theories suggested that Mars should be inactive with a surface that was relatively stable for millions of years. Nothing like the scale of Valles Marineris was even imagined. So then back to the question of what did carve up Mars like a pumpkin. In the 70s, Ralph Jurgens, a civil engineer and a participant with Dave and Steve Talbot in the magazine Ponce, thought that electric arcs between planetary bodies created the features we see on Mars, aside an area called Ganges Chasma, which is one of the deepest parts of Valles Marineris. And because olivine reacts with water, its presence seems to definitely exclude water erosion as the cause of the canyon. So we have to ask ourselves, what force is it that can excavate over 2 million cubic kilometers of rock and regolith from the Martian crust? And modern geologists speculate that Valles Marineris was formed by what they call mass wasting, meaning landslides or slow movement of material down a steep slope, usually in the presence of water. And since Mars is thought by many planetary scientists to once have been warm and wet millions of years ago.
In part 2 of this extended interview, we continue our discussion with Thunderbolt's Picture of the Day managing editor Stephen Smith on the electrical scarring of planets and moons. We now turn our attention to Mars as we explore the evidence that electrical discharges dramatically carved the Martian surface. We begin by asking the question, did excavated material from the surface of Mars arrive on Earth as Martian meteorites?
Martian meteorites, as their name implies, are supposedly pieces of the planet Mars that have reached our planet. They're usually identified by their mineral and isotope content, catastrophic flooding. But a major difficulty with that theory is that there's no delta or headwater region in the canyon, and there's no debris field that might be left over from water erosion. Also, there's no indication of surface accumulation of water anywhere nearby in lakes or ponds that might have formed because of the catastrophic flood that supposedly cut out the canyon. Also, the so-called tributaries in Valles Marineris terminate in clean cuts, and there's no sign of water flowing down into them. They don't look in any way like a typical drainage formation. The Mars Reconnaissance Orbiter also saw evidence of olivine